In this video, we'll look at how to implement an intrusion detection system using Snort. Snort is open source software, and it can be run in 3 different modes. We can run it in packet capture mode, which is what you're seeing on the screen right here. We can run it in logging mode, which means these packets are written out to the hard drive. Or we can run it in intrusion detection mode using the rule sets that are available with Snort. I want to give my thanks to Paul Tatarski, whom I met a few years ago at the Department of Energy training conference, and he kindly allowed me the use of some of his slides, although most of these now are my slides. But I just want to say thanks to Paul. Let's revisit the different types of intrusion detection systems that are available. Thus far, some of you have worked with Snort, and we know that Snort is placed on a network, and so it's listening to the traffic coming across the network, and therefore it's considered a network-based intrusion detection system. And generally, a network-based intrusion detection system is done at a single point of entry into a network. They're easy to employ, and they use simple rules, that is signatures for detection, and we've actually looked at some of those rules. And then the other type of intrusion detection system is one called the host-based, which actually looks at a security approach to a workstation. And a host-based means that the IDS is going to be placed on every host that requires it. And so what that does is it provides a detection of non-network-based attacks. For example, somebody sitting down at the computer and decides to revise certain files. For example, somebody sitting down at a server running some version of Linux and going in and trying to read, let's say, the password file or the shadow file, or trying to change one of the other configuration files so a specific service runs. Well, these are the kinds of things that may not be changed on a day-by-day basis, and therefore it may be something that the administrator will want to be notified about if those files changed. And so the great thing about host-based IDSs is that it will show you what's changed on a daily basis or a weekly basis. Realize that the host-based IDS is not affected by network traffic or switch traffic, but what it is liable to do is to succumb to a lot of false positives. So you have to be careful when you deploy a host-based IDS, because what essentially you're doing is you're saying these files that I want to oversee on a daily basis, I don't want changing on that frequent a basis. And so when those do change for whatever reason, you're going to be alerted to that fact. And so you have to be careful about those files that you choose to monitor. Okay, Snort, we've talked about previously, is a free open source intrusion detection system. It's very, very powerful. It's run by a lot of companies and a lot of different people who know what they're doing. And I can't remember if we touched on this before or not, but Snort can be run in 3 ways. It can be run as a packet sniffer, which is looking at header information. It can be used as a packet logger, so in other words, all it's going to do is it's going to take each packet and log it for later viewing by someone. And it can be used as an intrusion detection system. And the difference between these, the first 2, and intrusion detection system, is in the intrusion detection system is that Snort is actually applying the packet content that's flowing across the network to each of the rules that's indicated that's being used by Snort. And we'll see how to do each of these shortly. And so this is showing a general intrusion detection model. Let's make this a little bigger so you can take a look at it. Here we go. On the more simpler systems like for Snort, a lot of these things are going to be combined. But here we see you have a data source, which is going to be some sort of network connection, which is coming in, notice, to various sensors. And then the sensors are going to be the thing that's actually listening to the packets and pre-processing them, and we'll see shortly that Snort actually does that as well. It pre-processes packets. And that goes events to an analyzer to determine whether an alert should be issued. And then the alerts are issued, and that's actually sent out to the manager who's in charge of network security. And we see then that the manager here, and these are essentially technical devices right here, this network manager, then can notify a human operator. Notice down here, the system administrator or network administrator can take the security policy, which envelops this entire thing up here, and change the analyzer based upon the changes in the network security policy. Okay, so I don't know. I don't like how that's changing. Let's see if we can make it so that it's fitting now. The components of Snort. First thing is it's got a packet decoder, which processes packets from different interfaces. So you may have a SLIP, a PPP, or an Ethernet interface, and so Snort has to understand the breakdown of each of those packets. And so what a packet decoder does is it breaks down the packet so that it's understandable by Snort. And then it's got preprocessors, which modify packets before the detection engine. And there's various preprocessors involved with Snort. We'll look at some of those in just a second. But the reason that preprocessors are necessary is because intruders can modify the packets to try to evade detection. However, with the preprocessor, the preprocessing processors of Snort will go in and do what they need to do to normalize those packets so that then Snort can look at them in a normalized fashion. Here's an example of a preprocessor. So the rule, let's say, the signature is to find the text scripts /IIS admin. Now the question is there a way that a hacker could type this so that it would get by this rule? Because realize this is going to have to match exactly. Well, let's look down here. How could you modify this? If you had scripts /./, the ./ means what? /. It means the current directory. And so this is the same as this. However, in matching, this is not going to match this unless this is normalized or reduced to its canonical function, which would be this. Same thing here. Script examples /.// IIS admin. If you look at the // that means the parent directory of here, which means this now moves up to here. So once again, we've got scripts IIS admin. Here we've got scripts in IIS admin that have a / in between. And so an exact matching is not going to occur, but if you normalize this, it will. And finally, you have a / and then a ./, which reduces to this if you run it through a preprocessor. There's other problems too, is because web browsers understand hex and Unicode, and so when you substitute it for ASCII something in hex or Unicode, the web browser will understand it, the web server will understand it. However, if there's something that's requiring an exact match with the rules, it won't match. The other problem too is fragmentation, is breaking down a packet into multiple fragments. And so Snort has a preprocessor that actually goes in and takes the fragments and puts them back together and then supplies them to the detection engine to understand. And so Snort has preprocessors that can decode HTTP URLs, which is essentially what we're looking at back here, reassemble TCP streams and defragment packets and reassemble them. Okay, the detection engine is the next component, and it's used to detect intrusion activity in packets. And so essentially what it's doing is it's taking the rules and applying those rules to different layers of the TCP IP stream, that is the packets that are traversing the network. And so some of the information in these predefined rules that you may want to include as criteria include IP header info, for example, the IP addresses, source and destination ports if we're looking at the TCP level, whether something is an ICMP packet in itself. Down here you can specify port numbers, port ranges, whether a packet is TCP or UDP. Then we have application layer header information, so we're talking about things like FTP, SSH, TFTP, web, and so on. And finally, the packet contents. Sometimes you just want to look at the packet contents to determine if a rule matches or not. intrusion detection systems are time critical, and because the kernel may not be able to, or the detection engine may not be able to handle all the packets that are coming across the network, it may start dropping packets. And what Paul told me is that you want less than 5% of the packets dropped, because otherwise some of the packets will be getting through that shouldn't be getting through, or getting through undetected rather. Okay, other components include a logging and alerting. And so logging, of course, is just going to create log files, and some of you have already seen this when you used Snort in the previous assignment. It created a log file. It also created an alert. And alerts can be sent out to a log file, or as I indicated previously, you can actually beep the network administrator or security administrator if need be. Some of the information you may include in logging include the headers and/or packet contents. And of course, you want the alert, that is the rule that was tripped, so you know why you're receiving the message. And then you have output modules that allow you to control the formats of the log. And so most of you saw that the alert files, or alert.ids, came in text format. However, for quicker writing and reading, you may want to output the stuff in binary format, which then can be reread by TCP dump. Or you can log it to a database, generate XML content, or send Windows messages via Samba message, server message block rather, over Samba. Okay, we've already looked at some of this. Installing Snort, you may install it from a source or package, and we've already got an iClass or two up there that indicates how to install and run Snort for Windows and for Linux. We see that the rules are enabled within snort.conf. We've already seen that. And just so we're on the same page, what I've done is I've gone out to notice the directory etc snort. In here is our snort.conf file, and we want to take a look at the snort.conf file. And notice here we indicate the path for the rules. Let's go up to the top. Look for that. So we have to specify that the rule path is the current directory rules. That is the current directory where the snort.conf file is located. And then there's a lot of things in here you can change, like the preprocessors. Unless you're really getting in depth into this, I mean, in a real organization, you would want to go through here and understand everything that's in here. But we can't do this for this class because we got too much stuff to cover. Notice that this shows you how to output it to different databases: MySQL, ODBC, Postgres, and so on. And then if you take a look at the rules to include, it includes the rule path and then the rules to include. And of course, based on your security policy, you may not want to include all these rules. And so if the rules that you don't want to include, you're just going to comment out like this. And of course, this should all be driven once again by your security policy. For example, if you're not running IIS or front page or anything like that, or if you're not running any server, you probably don't want to include a lot of these web rules in here because it doesn't make any sense, and all it's going to do is it's going to slow down the detection engine. So if you're not running if you're not running Linux and X11, here's some things in here like the X11 rules that you don't want to include. If you don't have Oracle or MySQL databases on the network, you don't want to include those, because all that's going to do is that each packet goes by has to be compared against the rules in that rule base, and all it's going to do is to slow everything down. Let's run Snort in sniffing mode. I just see that it works. So Snort minus, in fact, let's go in here and look at man Snort, and I'll show you what these options mean. So we're going to run Snort in packet capture mode, and you can take this yourself. We're going to use D, E, and V. Notice that D is dump the application layer data when displaying packets in verbose or packet logging mode. Okay, we're going to use E for display log the link layer packet headers. Be verbose, print packets out to the console. So that's essentially what we're going to do. So we're going to type snort-dev, and what we're going to do is see the packets crossing. Notice that it's already gotten one packet. Let's move up a little bit. There's no real very little network activity. There we go. And so now what it's doing is just sniffing the network. Of course, we're on a switch, so it's only listening to what's on running across this computer. And of course here we see 9:27 at 12:26, so this is giving the date, the time, and the milliseconds. And notice right here is the MAC address of the incoming packet, the MAC address of the destination. And then below this, notice this is the MAC address, this is the actual IP, 192.168.0.9. This is the source IP and source port. This is the destination, oh come on, destination IP and destination port. Here. Protocol is UDP, time to live is 64, and so on. Notice that here, I know it's going across the screen, let's quit that just for now, there. Okay. So notice when we'll go back up in just a second. Notice there were 63 UDP packets, 0 TCP packets. When I was talking about TCP, that was for the transport layer, so there were 0 TCP packets, 63 UDP, 2 ARP, and 6 were fragmented. Very interesting. 8.57% of it was fragmented, so that's the output. It shows that it looked at 142 rules, and it dropped 0. And we can go back here and see some of the rules here. Notice that this is sending out a request to 255.255.255.255, which is going to be the broadcast address. And this is 0.2.138, so that's going to be NetBIOS, which is how Windows computers and other computers talk to Windows boxes. And so that's why you have this browse right here. It's actually looking for the name of a Windows box. Let me see what this is. 631 right here is CUPS printing, Common Unix Printing System 631, and this is my my G5, my Mac, is sending out something to 0.255 631 to tell the fact that what it's doing is announcing to everything on this subnet the fact that this printer is available here. Okay, if we wanted to do this in logging mode, we could do this. We're not going to type V, we're going to type -L, and well, first of all we have to make a directory here. So let's make a directory called log. So we've got that directory. Now I'm going to type snort-de-l. What this is going to do is going to type everything out to the log directory. And just give it a second to capture some things. Hopefully it captured something. Hello. There we go. And there's a Snort log file, and that should be in, I think that's in binary mode. TCP dump capture file. Okay, so let's write TCP dump -r snort.log. Let's just run it like that. Here we go. And so we've seen the packet sniffer mode, and we've seen the logging mode. In a second, what we'll do is we'll look at the intrusion detection mode of Snort. Let's go back here first, though. Okay, we've seen this. This is the intrusion detection mode, is that you have to give it the -C, because then it needs to read the snort.conf file, because that essentially is telling it, hey, here's a configuration file. I want to run this in intrusion detection mode. Notice it has the log directory right here. And then it tells us it's a little different on startup because it initializes the rule chains. It looks at all the different rules and all the different pre-processing available. Okay, this is what we saw before with Snort as a just looking at the packet headers right here. And so if you're interested in just doing something in real time, you can do that, but realize that it could be going very quickly by the screen. Here's an alert. Web client JavaScript URL host spoofing attempt, and it indicates the header of the packet that generated that, as well as the packet contents. And then, of course, as we've seen before, is the once you quit Snort, it gives you the results of what it's done. It tells you the breakdown by protocol, whether there's any wireless packets that are going by, any fragmentation, and whether the TCP stream reassembly stats has occurred. Okay, just so you're familiar with these packet headers, and I think we've done this for TCP dump, but let's look at it one more time for Snort. We have number 1 is the date of the packet, so this was on 3/31, doesn't say what year, but at 9/21:05 in so many seconds. Then we have the MAC address of the sender and the receiver, respectively. Okay, we have the type of service here and the length of the datagram, which is going to be in hex. Then we have the IP of the sender, the IP of the receiver. Here's the source port. Here's the destination port. Notice this is 139, which is going to be over NetBIOS. The time to live of 128, the type of service, the packet ID number, which is unique, the IP length, the datagram length. The don't fragment bit has been set. And notice that this is an acknowledgement flag, so this is acknowledging receipt of something that's come across the wire. Notice that everything has a sequence number and the acknowledgement number, which are going to be unique. And it shows you the window size and the TCP length. So things of interest in here in terms of creating a rule would be, I guess you could use the time, but I don't see that very often. The MAC address. The MAC address will uniquely identify a computer, whereas with the IP numbers don't, because those can be changed on a computer, but MAC addresses, unless you spoof a MAC address or you switch out a NIC from one computer to another, will uniquely identify a computer. And so the MAC address, the IP source, and the IP source port may be of interest. The destination IP and the destination port may be of interest. The protocol may be of interest. Okay, if we're going to run in something in sniffer mode. If we want to just print out the TCP packet header to the screen, you're going to type snort-v to see the application data in transit-vd, and even more descriptive display showing the data link layer headers to do this. So if we go back here and just type in snort-v, so that's just going to show you the headers. Now, if you type -d, whoops, that's not what I wanted, -d, it's going to give the application layer. There we go. So we get some of the content in there, the application layer. Come on, kill it. Kill it. There. And then -e for link layer. And that's when you get the MAC addresses. And notice right here is the MAC address going to broadcast MAC address right here. Okay, going back here. Here we're doing a packet sniffer. Notice this is a DNS packet. How do we know this? Several things. Is that this is going out to 53. So this computer here is sending out a request for a translation of a domain name to an IP address, because it's being sent to 53, which is DNS. And notice this is UDP, which is typically what DNS uses. Here's DNS replies in ARP. Here's the reply right here. Notice that right after this, that 6813.1630 replied to this. So this is actually sending back the mapping between the domain name and the IP address here. Notice these different times to live. Different systems have different times to live by default. So like Linux systems may have, and I can't remember this exactly, but most Linux systems may be 64. Yeah, I think this was. And the default for Windows is usually 128, and I think Cisco is 252. I don't know if that makes any sense. Here's an ARP request and an ARP reply. ARP, who has 192.168.1.1, tell this. So in other words, 192.168.1.100 wants to know the MAC address that's mapped to this. And so here, there's been a reply, and so a machine has replied back that this IP address is mapped to this MAC address. And so now this computer can go ahead and forward the packet to this address right here, because it's on the same subnet. Okay, here's where running Snort in packet logger mode, so it's going to collect every packet, and we saw that previously. So it places it in a directory hierarchy based upon the IP address of one of the hosts in the datagram. And so here what we're doing is we're logging all the packets, header information, application information, and MAC address information to the log directory. Here we're only logging things that are coming in to this address, -H here, and here we're logging in binary. And so that's going to be a lot faster than writing out into ASCII. And notice here when we're logging that it'll actually log based upon what you specify it to. So this is logging everything that's coming in here, and everything. This is a source address, and this was a destination address, local address. And this is the log directory we just saw. This is a binary file, so you've got to read it either with Snort or with TCP dump or some other program that understands it. And as we saw before, if we'd like to read that Snort log, we type TCP dump -R for read and give it the Snort log, and it tells us, it shows us the information in this file. This is interesting too. If you just want to view UDP information, you can actually type UDP after the name of the Snort file, and what it will show you is only the packets that were UDP. Okay, let's talk about Snort in intrusion detection mode. Okay, here what we're doing is we're specifying the fact that we want to run Snort in full intrusion detection mode. We want to use, we just want the headers, and we want to log those to this directory, and we want to use the configuration file snort.conf, which then should be in the current directory based upon how this is running, where you're running this from. If you'd like to make a Snort directory for the logs, you can make one var log snort if it hasn't already been made, or you can do it in the current directory. It really doesn't matter as long as you remember where. Okay, so here what we're doing is we're capturing header information, application information, and MAC information. We're going to log to this log directory in the current directory, and we're interested in packets coming into 192.168.1.0 CIDR 24, which would be everything from 0 to 255 in this last octet. And then our snort.conf file. So you could name this anything you want, but this just indicates where the location and the name of the Snort configuration file. Okay, there's also a file you notice called reference.config, and what this contains is references to allow display of additional information about the alert. For example, the type of alert, the categorization of the alert. Now let's look at some of the different rules that are available. You have attack responses, which are designed to focus on a server saying back to a client something it shouldn't be saying, often as a result of a compromise. Notice this is interesting because what this is saying is there's been a compromise on an internal system, and so the internal system is sending something back out to the outside world that it shouldn't be saying, which means that it appears there's been a compromise. And so this is not looking at packets coming in, it's looking at packets going out. Bad traffic contains some rules which may indicate stack attacks and other dangerous network traffic. Contains known shell code, exploit patterns, web attacks, web IIS. If you've ever seen some of these command exe get requests, these are based upon Windows Microsoft IIS web server. And those are just some of those. We looked at all the rest of them earlier, all the different categorizations of rules. Okay, let's stop this class right here, and we'll finish up next time talking, getting more into the actual rules, which you'll be creating for your next assignment.